Oke, oke. Yes, please. Mas Rifki, kasih hak untuk share screen.
Yes, sir.
Dr. Santi Gayatri.
Yes, sir.
Dr. Santi, do you hear me? Santi Gayatri. Gayatri Devi Daram, do you hear me? Santi, oke, Santi dia. Santi Silakarna. Santi ya, oke. So, would you like to present first, Dr. Gayatri?
Yes, sir.
Yes, please, ya. Dr. Gayatri dulu, Mas. Dr. Gayatri dulu, Mas.
Okay, sir.
Nggih, Prof, sampun saya.
Yes, you are now able to share screen then.
Yes, sir. Yes, sir. So the screen is visible now.
Yeah, it will be coming.
Hello, sir.
Yes, hello. Yeah, I can hear you.
Yeah. Okay, sir.
Yes.
Thank you. Good morning to all. My name is Gayatri Devi. I'm working as assistant professor, senior grade in Vellore Institute of Technology, Chennai campus. My area of specialization is artificial intelligence, machine learning, and deep learning. So today I'm just going to present one topic which I chosen for this international postdoctoral program. The topic is novel quantum-based learning architecture for autonomous navigation in self-driving applications. So this is a topic which I've chosen for my research program. So as an introduction, here I'm concentrating on
Dr. Gayatri, share screen is not visible. The share screen is not visible. Have you shared the screen?
I've shared.
Yeah. It's coming. No, it is cancelled out.
Shared window is closed.
It is cancelled out. Kenapa itu, Mas?
Ya, dari jaringan, Prof.
Dari jaringan. Ya, ini dulu. Coba lihat ini.
I think
Coba lihat mau minta tanda tangan dia. Sudah bikin vaksin untuk tulisan ya. Duduk dulu. Ya, sip sudah. Ya wis. Ya, berikan dah ya. Ya. Sekarang salam.
So Zoom is getting crashed multiple
Yeah,
times.
yeah.
I don't know what.
Shall I ask somebody else first? You just prepare your slide presentation later. What do you think?
That's okay, no problem, sir.
Yeah, okay.
Every time
Okay.
now, like for the past 2 days now, this is getting crashed. So I have
Oh,
to check for this.
yeah. Please check it. Yeah.
Okay, sir.
So,
Okay.
other Dr. Shanti Shankarnath, are you here?
Good morning, sir.
Yes. Good morning. So please share your screen.
Yes, sir.
Yeah, okay.
Are you able to see, sir?
Yes, I can. Please continue.
Okay, sir. Can I start, sir?
Yes, please.
Okay. So myself Shanti from Chennai. So good morning, dignitaries. So this is my first doctoral DC presentation. So am I audible, sir?
Yes.
I'm audible, sir.
I
Yes, sir.
can hear.
So
Yeah.
my topic is adaptive federated learning frameworks for the real-time detection and mediation of APTs in multi-cloud systems. Uh, so these are all the contents I am going to present. Before I start, I will give a short introduction about myself. So I am Shanti. I completed my PhD in 2025. So I have 10 plus years of teaching and research experience. I am currently working in Krishnaswamy College for Women, Tamil Nadu. So I am the research department assistant coordinator and coordinator of Vidya Vikas cell, member of placement cell. So my areas of interest are cloud security, data mining, deep learning, machine learning, and artificial intelligence. So this is my research topic for our postdoctorate. So it's talking about the abstract. So the multi-cloud adoption enhances flexibility, but also expands the attack surface, exploring a system to advanced persistence threats. So traditional detection systems struggling with certain factors such as latency, privacy, and adaptability challenges. So this A filtered is a real-time APT detection and mediation across heterogeneous clouds. So it will integrate secure aggregation, differentially privacy and adaptive models, updates to handle evolving non-IID threat data. So through this spital temporal deep learning and feedback-based architecture, app filter improves detection accuracy. It also reduces the response latency and resists adversarial attack, advances privacy preserving intelligent cybersecurity for modern multi-cloud environment. So the primary thing we have to start with, so the motivation behind this research is we are facing some high latency and communication overhead in terms of the existing traditional intrusion detections, the risk from centralized data collections, then poor adaptability to eval attack patterns. So this is the primary motivation behind this research. So introduction about the APT or APT detections. So the factors that are part of this thing is the rise of multi-cloud infrastructure, understanding advanced persistent threats, challenges in traditional centralized detection, introducing adaptive federated learning, certain benefits in terms of cipher defense frameworks. So when we talk about the rise of multi-cloud infrastructures, we have transformed enterprise agility and scalability. So this can be expanded as a cybersecurity surface. So when we are using the APTs, So they are characterized by their strength and persistence. So the specifically targeting on multi-cloud environment requires advanced detection methods. So in terms of introducing advanced term methods, we can somewhat rectify the problems in our traditional methods. So centralized detection methods struggling with facing latency issues. So the privacy concern will be a higher end, which has a limitation towards the traditional methods. Then AFL offers a privacy preserving approach in terms of the detection. This method enables collaborative model training across distributed clouds. In terms of cyber defense frameworks, AFL addresses the latency and privacy issues. It also enhances the real-time detection capabilities in compacting APTs within the multi-cloud environment. So what are all the problems we are facing in terms of the multi-cloud APTs are latency and communication challenges, privacy concern in terms of data sharing, and non-IID and heterogeneous thread data, adaptive federated learning as a solutions. So in terms of latency, the traditional APTs are having enough detection tools, but we will not able to rectify the latency to a certain level. So the communication delay in terms of the multi-cloud scenarios hindering the ability to respond to the threats in the real time. Privacy issues arises due to the limited sharing of raw data across the cloud tenants, so leading to significant constraint in collaborated threats detection efforts. So the diverse nature of threat data, including the non-IID characterizers and heterogeneity found across the multiple cloud environments, so that will challenge the consistent model accuracy in APT detection system. So addressing these challenges necessitate an adaptive federated learning framework, which will aim to enable real-time privacy detection and mediation within the dynamic multi-cloud environment. So the primary research objective is that developing an AFLF, that is adaptive federated learning framework for real-time detection and mediation of advanced persistent threats across the multi-cloud. The secondary objectives are listed here. First one is adapted model updates. This will be helpful in terms of heterogeneous node to enhance responsiveness as well as the effectiveness. So the real-time thread intelligence integrated real-time thread intelligence feedback into their framework for continuous improving in thread detection and responses. So aggregation robustness, the robustness will play a vital role in terms of working on a multi-cloud environment, implementing a robust, that is by genting resilient aggregation technique to counter poisoning attacks and freeloading behavior by faulty behaviors as well as the faulty nodes. So privacy preserving techniques, employing advanced privacy preserving techniques such as differential privacy and secure multi-part computation to ensure security and confidentiality. The last one is the evaluation of framework effectiveness, evaluate framework for accuracy and latency, communication efficiency, and scalability using multi-cloud datasets and stimulating the
What's wrong? Is it? Yes. Shanti, are you okay?
Sir,
Yes, yes.
sir, it was disconnected. Sir. Sorry. Some network issue.
Yeah, yeah, yeah.
Okay, sir.
Yes, sir.
Shanti ma'am. Shanti ma'am, can you hear me? Hello. Hello, Shanti ma'am.
Anda bisa mendapatkan keuntungan yang
Shanti ma'am, can you hear me? Brother Rifki.
Yes, yes. I already asked her, but she has internet connection issue.
Okay.
Yeah. Actually, previously, Gayatri also having a problem.
Okay.
Right now, Shanti already presenting some of her slide, but
Okay.
she has got a connection. So I already Gayatri again. Are you ready right now?
Yes, sir.
Yeah,
Ready.
yeah. Please now you can share your screen.
Yeah.
While waiting Shanti Shankarna fix her connection issue. Yeah. Yeah, it is good.
It's visible, sir.
Yeah.
Yeah, it's visible.
Okay, sir. I'll introduce myself. I'm Dr. S. Gayatri Devi. I'm really thankful to you all people for giving me an opportunity to be part of this international postdoctoral research program. So here, I'm working in Chennai, India, as assistant professor, senior grade 2 in Belur Institute of Technology. It's a university. My specialization area is, as I said, artificial intelligence, machine learning, and deep learning. Along with all any of the SDG goals, now I'll try to inculcate as part of my specialization combinations. Here now I am working with many patterns, pattern works. Few it got published also in VIT. Totally, I'm having around 13 patterns. Still 8 more there in queue. Other than that, I'm having 2 books, like few book chapters, 6 SCI e-papers, and a normal Scopus index papers. Even I've completed my IELTS examination, just for having like the quadrants, whatever they are having now, the levels, just to know about that. So for this research program, I've taken this topic. The topic is novel quantum-based learning architecture for autonomous navigation in self-driving applications. Even though I've started with this pattern for like paper, journal publication, I'll try something as part of pattern also in like this broad area. So that is also I'm trying to do. I'm just doing research, literature survey regarding this particular topic that is autonomous navigation. So I'll try to do my best. So now I'm going to start with my presentation. Few things which I have researched. So I'll present to you people. So the topic is novel quantum-based learning architecture for autonomous navigation in self-driving applications. So this autonomous navigation necessitates intelligent decision-making systems. So we can adapt to complex and dynamic environment. That is the main part. So what is the exact research challenge which I've taken is the environment, when we are using navigation environment, when we try to apply the deep reinforcement learning, that is RL methods, even though we have demonstrated, that is previously we have effectiveness, we suffer from prolonged convergence times and sensitivity with respect to the hyperparameter settings. So that's the main research challenge which I've just taken as part of this work. So the next slide is. So how I'm going to address the research challenge? What is my objective? So here I'm trying to introduce dynamic vortex search-driven quantum proximal policy optimization. This optimization technique I'm trying to introduce as part of my postdoc. So this I'm going to present as a novel hybrid framework. So that what were the previous challenge which I told, mainly in terms of efficiency and stability related to deep reinforcement learning based navigation system. So this is what I've learned about. So this is just a slide which is used to show the key components of autonomous navigation in terms of self-driving vehicles. So these are the parameters which we are just going to consider as part of this autonomous navigation. That is safety and reliability, regulatory and legal framework, along with system architecture and integration. So for this example, safety and reliability, what we are just going to try, establishing a consistent regulatory framework for autonomous navigation systems, and then addressing legal and liability aspects in complex accident situation. So these are the key components which I'm just going to consider for my autonomous navigation and self-driving vehicles. So the next one is literature review. I've done around 10 papers as a part of my research survey. So I've just taken the aim for each and every paper. Even references I've just given. So as part of each and every paper, I just come out with advantages and the limitations. Maybe the gaps also I've tried to identify along with that. Even I've noted down all the results, what are the end results which we need, so that I can make a comparative analysis of the existing and the proposed work. So totally 10 papers. Now I've started with and ended with a few papers yet to be added in the near future. So the limitations mainly is in terms of complexity, the speed and scalability. So all these things I have to fit for the Indian road conditions also. So these are the survey gaps which I just identified. So for this purpose, I'm going to use a synthetic data set, which can be generated by this simulator, which is called as Carla, where I will try to just note down about the diverse urban driving conditions, such as parameters like fields, intersections, pedestrian zones, and variable weather conditions also. So this is the flow which I've just planned for. This is the flow which I've planned for. After the data collection, I'll be doing data pre-processing. So in the pre-processing, I will be considering modified Z-score technique as well as normalization related to min-max scaling also. And that one will be passed to feature extraction, where I'm just using convolutional auto encoder. Followed by that proposed model, where I'm just going to use that optimization technique, which is called as TVS QPPV. Finally, I'm just going to, after the experimentation, the results, I'll be considering all the parameters such as accuracy, F1 score, precision recall, along with the pedestrian detection rate and collision avoidance rate. So this is how I planned the flow related to my work. So all these things, whatever I just given or depicted in the diagram has been given here. So these are the references which I just given as part of my work. Hello, sir.
Yeah, Gayatri,
Yes, sir.
it is fantastic presentation.
Okay, sir.
Since
Thank you.
you are using a quantum-based learning architecture for
Yes,
autonomous.
Quantum-based learning architecture.
Yeah, autonomous navigation.
Mm.
And previously you said that it is there are a lot of patent that you already developed. Is it right?
Yes, sir. One
Oh,
example is,
fantastic.
see,
Yeah.
already I've done 3 patterns. It got
Yes,
published. Other
yes.
than that, still more are there. Maximum it's with students only. Few are mine own, and maximum is with students. One example is flower creation system. What in India now we do know flower knotting. For events, and girls keep flowers in head, like
Yeah,
flower
yeah.
knotting system one.
Okay, okay.
During the COVID period, the robotic arm, which is used for injecting, because
Okay,
at that
okay.
more no nurses and other staffs are needed. We were not able to maintain it at that period. So one simulation was done by my student. It's related to robotic arm, just for
Okay.
injecting only this arm.
Yes, so you are
Again,
from,
this time I've submitted many.
yeah, you are from electrical engineering, aren't you?
No, computer science engineering.
Computer science engineering.
Yes, sir.
Yeah, yeah. So, how do you deploy the model when you already run and study the effectiveness of the model along with the computer simulation? I believe you already have some deployment in the machine to have a prototype such that you got a pattern. You got a patent. Have you done a deployment of the machine, of the coding that you already developed?
No, technology transfer, now only I've started. All utility pattern has been published. Technology
Okay.
transfer I can't do for all at a time. Now
Hmm.
I've started with one prototype, which is done by
Okay.
student guidance. But
Yeah, yeah.
soon I'll give one my pattern.
Okay.
I've
Yes,
started
yes.
my work. Still
Yeah.
in process. It takes
Okay. Very
and
nice.
components is needed.
Yeah, very nice. Yeah.
Okay, that's why still it is in progress.
Okay. And then you mentioned that
I
it
try
is
to give one.
considered, you mentioned that it is considered to be reinforcement machine learning type. Yeah. So can you tell me a bit about the type of the data that you have in the what experiment? What kind of data when you have what
This one.
taken? Yes, yes. What type of data? It is numerical or it is image data?
No. Still now I have to simulate. That's a synthetic data set which I've just framed. Still I have to start my work. All the data set I have to simulate it, and I'm yet to start. This is
Hmm.
simple, just which I've just given.
Okay.
Full
But
I'll start soon.
have you predicted that the data will be in numerical data or in the image data?
Uh, so this is related to the deep reinforcement learning.
Yes.
Even though it is numerical only, we'll try to have. I'll
Ah,
try to have. But even though something which is related to images also, that is also possible. But
okay.
main priority is given to numerical.
Okay, okay. Yeah, yeah, yeah. Yeah, okay. Good luck then, Gayatri. Very nice, very nice. Yeah. Okay. Thank you very much, Gayatri. Okay.
Okay, sir. Thank you. Thanks a lot.
Yeah. Yes, yes, yes. You're welcome.
Okay, sir.
Okay.
Shanti?
Yes. Santi, are you here?
Yes, sir. Yes, sir.
Yes, yes.
So
Please continue because you have got
yes, sir.
what
I got
connection
some
issue.
disturbance due to the network, sir. So I will start. Can I
Yeah.
start from the beginning or where I left?
No, I just continue with the what the continuous the
Okay, sir.
slide. Yeah,
Okay, sir. I
continue
will
the
start
slide.
from the objective, sir. Okay, sir.
Yeah, yeah.
So the primary research objective I have already stated, but due to some lack, I am repeating the thing. So primary goal of the research is developing an adaptive federated learning framework for real-time detection and across the multi-cloud environments. Though the objective can be secondary objectives will be enhancing the adaptive model by means of heterogeneous nodes to enhance system responsiveness. So it also works on real-time threats, that is through the intelligence feedbacks and the feedback from the existing history or all those things we can consider as a real-time threat intelligence. Then aggregation robustness, one of the major crises we are facing in terms of multi-cloud environment is the robustness. We are implicating by Xantic resilient aggregation technique to counter poisoning attacks and free-loading behaviors by faulty nodes. So the privacy preserving techniques employing advanced preserving techniques such as differential privacy and secure multi-part computation to ensure security and confidentiality. The evaluation of this framework effectiveness can be laid out to certain factors such as accuracy, latency, then scalability to multi-cloud data sets. So the background, we start with three backgrounds. That is, we are going to state about the three important backgrounds regarding this advanced persistent threats. First one is we initialize access, then persistence, lateral movement, then privilege escalation and data exfiltration.
ஒருத்தவங்க கான்ஃபரன்ஸ்ல இருக்காங்க, யாருமே உள்ள வர மாட்டாங்க. கொஞ்சம் என்ன சப்போர்ட் பண்ணுங்க சுந்தர் சார்.
Sir, Yes.
Yes, yes,
Then the
Gayatri ma'am.
background,
Proceed.
Shanti ma'am, Shanti. So background, then federated learning in terms of intrusion detection. So in terms of intrusion detection, the federated learning enables decentralized training by aggregating local model updates, preserving data privacy. Then in terms of IDS applied to intrusion systems, that is FL support cross-device and cross-cloud collaboration without a raw data transferring. Then current focus on the FL-IDE solution is that existing FL solution typically focuses on the accuracy and privacy. We are trying to extend the factors to the next point of robustness and preserving the data. Then challenges in the real-time usages, FL-IDS lacks optimization for real-time latency and multi-cloud heterogeneity. When we are working on multi-cloud environment, we are having some real-time latency when that has to be somewhat controlled by this new approach. Then needs for APT sequence modeling, FL-IDS solution requires improvement for advanced persistent threats, sequence modeling. The key issue in communication efficiency and resilience, that is challenges remain in communication efficiency and resilience against adversarial attack in distributed environment. So the multi-cloud architecture and edge computing as a background, when we look at the factors, means edge computing and latency reduction, then federated learning with fog orchestration, then challenges in multi-cloud federated learning, then bandwidth, that is the major issue, bandwidth and regulatory constraints, then adaptive aggregation for efficient collaboration. These are all the backgrounds. The primary goal in terms of this thread model and the design goal is the strength is that APT attackers executing strengthen multi-stage campaigning, targeting network and host telemeters, potential poisoning of model updates and privacy inference attacks. The weakness is that capability for real-time detection with bounded latency to contain lateral movements. The opportunity leads to the privacy preservation approaches, including differential privacy and secure multi-path computation. Raw data remains the local. Then threats, dealing with the robustness, that is where Myxantin and malicious clients, partially trusted environment with honest-based curious aggregation poses challenges. These are all the threat models and design goals. These are all the strength, weakness, and the opportunities that led to the threats. The proposed method is consists of 5 phases. The initial phase, we are reviewing the existing literatures that focuses on the federated learning framework and advanced persistent threat. So then in multi-layer system design, we are going to develop a multi-layer adaptive architecture incorporating secure aggregation and real-time feedback mechanism. The feedback plays a vital role in terms of deriving the data sets. Then creation of adaptive FL model. So utilizing advanced deep learning techniques alongside defense mechanisms to create adaptive federated learning models. Then in terms of stimulation and implementation, testing and implementation in stimulated multi-cloud environment using actual cloud platforms and open source frameworks. The evaluation is based on assessment based on various metrics, including the accuracy, latency, communication, overhead, robustness, and the privacy performance. It can be done in a phased manner. In terms of literature review and system design, it is categorized into 5 factors. One is analyzing the federated learning algorithm, reviewing of advanced persistent threat detection models, then proposed system design structure, then integrating of real-time threat detection mechanism. That is, whenever we are working on a large flow of data, so quick detection of threats. Then feedback-based adaptation modules, that is incorporating modules for continuous learning and model refinement. So the feedback system plays a major role in terms of capturing the data. So the feedback systems to balance the performance with privacy and resilience. So model development. So model development, first one is we have to add, I am going to adapt a federated learning algorithm, development of deep learning algorithms such as CNN, LSTM and transformer based algorithm. So these algorithms are aimed at capturing spatial and temporal threat patterns efficiently. They are working on real-time applications so that they can easily identify the temporal threats patterns, so which will be a source of data set for us. Then dynamic weighting strategy for node contribution, that is evaluation of client contributions based on data quality and node reliability. The implementation of this dynamic weighting technique, this will enhance the model valuation, and we can predict the intrusion detections in an well and efficient manner. So we can give a higher level of robustness and as well as the accuracy. Then defense mechanism against the model threats. So utilization of Byzantine resilient aggregation to maintain model integration. So the integrating of anomalies aware updates to agitating poisoning attacks. And the last one is privacy preservation technique integration in terms of applications that will ensure that will be in a multi-cloud environment. They will enable the confidentiality. They have to impose, they have to ensure the confidentiality in terms of the data. So use of secure multi-path computation for protecting sensitive data. So in terms of implementation, so we are going to stimulate multi-cloud environment. So the platforms such as AWS, Azure Cloud, Google Cloud, and open source tools like OpenStack and Minet to stimulate multi-cloud environment. That is the first factor we are going to do in terms of the implementation. In terms of deployment of federated nodes, we are working on federated nodes and central coordinators using Python-based frameworks that will include TensorFlow federated and by Python Scifit. So utilization of threat data sets such as, so we are well-known data set CICIDS 2017 and DARAP APT that will let out some traces of intrusion detections. We are maximum going to utilize the synthetic and real threat detection for training as well as the testing purpose. The data sets can be extended if it is proposed to use these two data sets. Establishment of secure communication protocols. This will be establishing a secure communication and aggregation channel, ensuring privacy and aggregating to compliance requirement. The evaluation can be laid out. First one is the data set. We are going to employ these data set. It can be further extended. Then metrics is TPR and FPR. Then latency, robustness, under poisoning and privacy leakages. The baseline is centralized local only standard FLIDS. So then procedure is stimulated multi-cloud environment that stress test with Byzantine technique. So the evaluation metrics and procedures. First one is evaluating the federated learning framework on key parameters such as detection of accuracy and privacy against APTs, then responding latency suitability for real-time containment, communication overhead to ensure scalability, then robustness to adversarial model poisoning and freeloading clients, comparative analysis with the centralized and conventional F-line baselines will be a benchmark improvement. So this will be the evaluation metrics and the procedures. So the expected outcome is adaptive federated learning framework that will enhance the latency. It will lower the latencies and enhance detection capability, scalability, and privacy towards preserving the federated models, academic contribution to the knowledge, then potentially industrial implication has to be the final expected outcome of this research paper. Then scopes and limitations, we have certain limitations. The first one is we network bandwidth availability and variability impact system. So that will be a major constraint and challenge for our research. Then dependency on synthetic data during initial evaluation rises questions of external validity. Then challenges in ensuring seamless participation of diverse cloud nodes. The key focus areas regarding our research paper is federated learning based adaptive intrusion detection mechanism that will emphasize the factors which are a major constraint in the real time in the traditional methods, targeted towards multi-cloud environment with real-time detection capabilities. And the last one is automated approach for shift containment of IAPTs. The OPUS research question, optimizing the trust scoring in non-IID environment, measuring the privacy leakage in graph temporal models, balancing automated meditation with human oversight. These are all the things we are proposing in our research paper. So this will when it works well, we will get a detection and meditation APTs in multi-cloud environment, and which will ensure the preserving the integrity of the data, as well as it will impose the privacy of the users in a multi-cloud environment. It combines vital temporal modelings, adaptive aggregations, and real-time meditations for practical deployment in a critical infrastructures when there are multiple clients accessing the data. So thank you, sir.
Very
Sir,
fantastic, very nice, Shanti. Yeah, very good. Yeah,
thank you, sir.
yeah. So I just wonder about the example of an advanced persistent threat in the what multi-cloud system. Is it like a virus or what is it
So
actually?
it is an unauthorized access, sir. So it will get our. It is like a cyber attacks. So they will
Hmm.
try to collapse our privacy. So when
Hmm.
intruder,
Okay, okay.
unknown intruders will enter the data, so that we will lose out the privacy regarding our data.
So if we have a good what cryptography system, because when you are saying that someone introduce some unauthorized person, for example, reveal the what the firewall and then the what password and everything, then why don't we enhance and advance the crypto system like encryption and decryption method, because there are a lot of crypto system mechanism right now, rather than
Yes,
we
sir.
are
Yes, sir.
we are what using a machine learning, because a long time ago when the machine learning does not exist, normally people using what advancing the crypto system, so the cryptography, for example, using what uh, right now we have a lot of modern cryptography.
Yes,
What do you think?
yes. Yes, sir. The cryptography, this is also one of the framework we are suggesting, sir. Cryptographic
Mm,
techniques are they are working with, my PhD topic is based on intrusion detection with machine learning only, sir. So,
yeah.
but we can extend them to the multi-cloud environment. This is one of the suggestions we are giving. It will enforce higher level
Mm.
of robustness, and it will reduce the latency.
Oh, okay. That's very good. Very good. Yeah, not I have got some information from internet. The what example of advanced persistent threat, for example, in multi-cloud system such as Stucknet. Yeah, Stucknet. Stucknet was a sophisticated malware designed to sabotage Iran's nuclear enrichment program. Yeah. So that is the benefit in the future. For example, you can also prevent some threat from any others. For example, in this case is nuclear enrichment program and also the other programs. So what is the main aim do you want to protect actually in the cloud computing?
Sir, yes, sir. So we in this research we doesn't focus on any one particular malware or any type of thing, sir. So
Yeah.
we don't want to let out our work. So we want to get the work completed by avoiding identifying these factors prior, so that our normal work will not be disturbed by this. We are not finding any solutions. So we are giving a framework to avoid all those things and get a good output regarding our work, sir.
Okay, okay. That's very good, very good. Yeah. So good luck, Shanti. I believe
Yes,
it
sir.
will be a good paper in the future. Hopefully, you can finish the paper soon. Yeah. Good luck.
Yes,
Yeah.
sir. Yes.
Yes, yes.
Yes. Thank you, sir. Thank you so much.
Yeah, you're welcome. Anybody else? Sharavanan, are you here? Someone?
Yes, sir.
Yes, yes. Shanti already, Gayatri already. Yes, your turns,
Yes, sir.
Mister. Yeah, please. Yeah,
Yes,
be
sir.
ready.
Shall I join, sir?
Yes, yes, yes. Mas Rifki,
Yeah, Prof.
sudah. Saravanan,
Yes, sir.
Saravanan.
Yes, sir. Yes, sir. One
Yes.
second.
Can you share your screen, please?
Yes, sir. Yes,
Start.
sir.
Yes, yeah.
Sir, one second, sir. It is some technical issue. A very good morning, sir.
Yes, very, very good morning. Okay, please.
Very good morning to Professor Tafik, Professor Dr. Sundar, sir, Professor Augustine. Very good morning to everyone. Today I'm going to explain that abstract of my project work, what we are going to do in the postdoctorate. The title of the project is Dielectric, Magnetic and Electromagnetic Behavior of Doping Fe3O4 Magnetic Viscous Natural Fiber Epoxy Composite, a characteristic studies. So here, what is the aim of our project means? One second, sir. Sir, whether you are able to see my screen?
Yes, I can. Yeah.
Okay. So the objective of our work is to develop a study for a ferrous oxide doping viscous fiber reinforced epoxy composite for electric, magnetic, and structural applications. So normally that composite what is available now, that is having some more weight, and it is not having any property which is required for our applications. For example, dielectric and magnetic properties. So for overcome the project, we are planning to develop one natural fiber reinforced composite to overcome the problem which is available in present. So now we started that work, sir. So we already prepared that composite materials and the natural fiber which is we are planning to do, that is we collected and we started that experimental work. So here that what are the experimental highlights, what are the expecting outcome means that Fe3O4 nanoparticle will increase the interfacing polarization and magnetic losses. So that will application that is increase the application of high temperature applications where when the temperature is maximum means that expansion will increase. To avoid that one, we are increasing that nanoparticles with natural epoxies. Then that what we are planning that Fe3O4 nanoparticles will enhance the electric conductivity and dielectric constants. So here electric conductivity is some of the place while adding the natural fiber and that composite, that electric conductivity will decrease. So because of that decreasing of electric conductivity, we are not able to use for 100% efficiency. So that property we already checked. So the FeO4 nanoparticle having more amount of electric conductivity. So while using that composite material with that natural fiber, there is no change in electric conductivity, there is no loss also. So then along with that electric conductivity, we are planning to find the mechanical properties that such like tensile strength and density flexibility. So this will increase the tensile strength. So the same type of material we can use for construction material also. So now only in starting stage, sir, we already now only started. Initial stage of testing is completed. So we are working on the paper, working on the results of working on the experimental work, sir. So up to now, we did only the material selections and that preparing of composite material with nanoparticles, sir, then natural fibers. So up to now, we completed this one, Lisa. Next presentation, I will give detail progress, what is happened. I think next presentation, I will publish one paper also. So we are in initial stage, sir.
Okay. Okay, Saravanan, sir.
Yes, sir.
So you have already started your literature survey and all, right?
So literature survey already when it will over before 1 month itself, sir. Now we started the experimental work, sir.
Okay. Once you have finished, immediately started to write the article.
Yes, sir.
Okay.
Now already started, sir. Experimental work at parallel it is going.
Okay.
Today I'm not able to present the result because the result we are not getting what we expected. Now we are changing some of the properties in that natural fibers and Fe3O4 nanoparticles. So once I got that result which we expected, then I will explain everything, sir.
Okay. Yes.
Thank you very much, sir.
So
Yes.
this is from chemistry study, yeah?
No, sir. It is from mechanical, sir.
Oh, mechanical study. Yeah, mechanical, yeah. So normally in mechanical engineering, what composite material is the best choice right now?
Actually, now presently aluminum oxide
Yeah,
composite is combination of different materials, sir. Based on the application, lot of composite material available, copper with magnesium.
yeah.
The temperature we want to withstand more means they will add cadmium, sir. So likewise, it is depending upon the applications. Lot of composite material available,
Lot
even
of
though in
composite,
IC.
yeah.
Even
Yeah,
though in
yeah.
IC engine, aluminum composite material also used, sir, to reduce the weight and increase the temperature nature. So this is for high temperature application we are planning, sir.
Yeah, yeah. So at the end of the your study,
Yes,
which
sir.
is written in your paper actually in the future.
Yes, sir.
So
Yes, sir. Yes,
what
sir.
is it is will you use like mathematical simulation to test the
Sir,
best
here
composite that you will have in the future, or what? Tell us, yeah.
actually, this is not mathematical study, sir. It is only for experimental work, sir. Fully experimental work based on the applications we are planning to implement in particular place for applications. We are comparing with previous material and what we
Oh,
invented that material. So it is purely
okay.
experimental study. There is no mathematical study, sir.
Okay, okay. So you don't use also machine learning or everything?
Machine learning possible, sir. Machine learning
Ah,
possible. That will planning for second paper, sir. First paper only mechanical characterization or study only. Second paper
mm.
we are planning for machine learning approach, sir.
Okay, so what is the indicators, some indicator that you will study to know the efficiency or the
Y-
effectiveness of the composite material that you will compare, that you
Yes,
will
sir.
study?
That is why
Yeah.
three things, sir. One is
Yeah.
thermal electric conductivity study, sir. This
Okay.
is based upon the electrical conductivity nature. Another one based on the strength, sir. Material strength. Different type of strength is the tensile strength, compressive strength. So we are planning for tensile strength, sir.
Okay, okay. Yeah, yeah. So if you use composite material, for example, for electrical vehicle, for example, don't you also study about the what the vehicle indicator like speed and also energy consume or everything? It is possible also in the
Yes,
future.
sir. Yes, sir.
Yeah.
Yes, sir. Sir, composite material means based on
Yeah.
the application, we want to reduce the weight means they will add aluminum alloys and
Mm.
composite material to withstand. Aluminum means it will not withstand the temperature, it will melt. But while adding that composite material, automatically it will increase the strength. Based on
Mm.
the strength, which material having more strength, that material will add some percentage. So based on the study, we will include that composite material that will reduce the weight of the vehicle. Because of reducing vehicle, that mileage will increase. Not
Mm.
only electrical vehicles, sir, normal two-wheeler also we will use such type of composite material for replacement of some of the equipments. Nowadays, that tire rim is converted to steel to composite materials, sir, to reduce the weight and to increase the strength also.
Yeah, very fantastic.
Yes, sir.
Very fantastic. Yeah. So, so this composite material also in my university
Yes, sir.
include a lot of researcher to develop about the
Yes, sir.
composite. But the issue is now rising is the how to decrease the pollution related the composite material.
Yes,
It
sir.
is also an important concern, the pollution. Yeah.
Yes, sir.
Yeah. For example, if you use battery for the electrical vehicle, then if you don't use this battery anymore, then how to store the and use the battery, for example. The production of composite material, it is sometimes also give the negative
Pollution, sir.
yeah
Yes, sir.
issue. Yeah, yeah. But it's
But
okay.
here,
Yeah, yeah.
sir,
Okay, please. Yeah.
sir, here we are using natural fiber, sir. Natural fiber.
Natural fiber.
If
Okay,
if
okay.
you burn also, it won't create any pollution, sir.
Okay, okay,
So such
okay.
type of natural fiber only we are using. Now we are testing with banana fiber. We are testing with
Mm,
coires. So different type of natural fiber using with that Fe3O4 material, sir. So now that
mm.
if you melt also, if you heat also, that won't give any pollution, sir.
Very good then. So if you use the what organic material for developing a composite or organic fiber. That's very. But how to do you consider about the cost? It will be high. It will be costly actually if you convert from organic fiber into a composite material rather than using the normal material, for example. It is also maybe in the future. It will be challenging. Yeah.
Yes, sir.
Yeah. Apart
Actually,
from yes, please. Yeah.
previously, lot of natural fiber epoxy composites available, sir.
Hmm.
But the proportions we are adding with nanoparticles that will enhance the heat transfer rate, sir. That is
Okay.
the reason because that is only this is only study, sir, an experimental study. So we are doing one a different type of natural fiber, and the proportion of composite material also we are changing for 5%, 10%, 20%. Likewise, we are changing in particular percentage and particular different type of fiber. That performance we are expecting that that thing we are planning to achieve, sir.
Yeah. That's very good. Yeah. Okay. Good luck. Hopefully you can finish the paper soon.
Yes,
Then we
sir.
will try to improve and also give some suggestion and contribution. Yeah.
Yes, sir.
So
Thank you.
thank
Sir.
you very much. Thank you very
Thank you very
much,
much for your
Dr.
suggestions, sir. Thank you, sir.
Paravanan. Okay, thank you very much.
Thank you,
Thank you,
Tafik, sir.
Saranand
Thank you,
sir.
Sundar, sir.
Thank you. Thank you.
Thank you, sir.
Yeah, brother.
Yes, is it finished already?
Yeah, finished. That's all. Rest of the candidate we can conduct
Yeah,
next
arrange.
week, brother.
We can rearrange next week. Yes, brother.
Yes, brother. Brother, two more things I want to discuss.
Yeah.
Yeah. See, this paper submission, okay, into the LMS. Okay, you give me the guidance
Yeah.
because
Okay.
most of them already they have finished the paper and they
Yeah,
are waiting for
Rifki.
your approval.
Yeah, just I talk with Rifki. Rifki.
Okay,
Ya,
Prof.
mendengar tadi tentang manual booknya untuk upload file paper ke ke e-learning, ke LMS ya.
Okay, Prof.
Nah, segera diproses ya.
Okay, Prof. Siap, Prof.
Supaya mereka bisa upload. Kalau sign up-nya sudah ya.
Sign up-nya waktu itu sudah.
Enggak, maksudnya peserta itu sudah semua enggak? Coba dipantau ya.
Oke, saya coba cek sistemnya, Prof.
Ya. Okay, brother, I already give some what suggestion to Rifki to finish soon the manual
Okay.
user manual for uploading the paper in the LMS here.
Yes, brother.
So
Then
the other one, the second one, yeah.
second thing regarding that Vishal Goyal. Okay.
Yeah, what? Yeah.
That
How is he? Yeah, okay,
yeah,
yeah.
he's
It's
good
okay, it's
and
okay.
he is looking for a visiting professor. Okay.
Yeah, definitely, brother. Actually, uh, one thing that I a little bit worry last time when he offered to me and then request to me, he said to me to write an invitation, and it is what signed by a rector.
Okay.
Yeah, so I am as a dean. Normally, I can sign it.
Okay.
If yes, then it will be simple then.
Okay.
But if you ask me to go to further upper level, it will be take time, but also because in our system also it is not it's little bit easy, but if we use this system. Yeah, this is that I'm thinking. Why
Okay,
don't
brother.
we use our signature from my what position right now as a dean? Just say to him, yeah.
Yeah, sure, brother. I'll check
Yeah.
with Vishal Goyal. Okay. If it is your level, then it can be easy for giving the
Yeah,
visiting.
definitely. Yeah.
Okay.
Yeah.
So that I will check with Vishal Goyal. Okay, then I'll
Yeah.
update you.
Because in the what our system already there, but the this one visiting professor
Okay.
Visiting professor. Yeah, it is. Okay, here. See, visiting scholar, adjunct professor. Yeah.
Okay. 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 Oh, in LMS.
Actually, we already have this. Yeah,
Can you show
LMS
me?
is already there. So
Okay.
I
Okay.
already show you. Yeah, please. Yeah. Yeah, this is okay.
Okay. Okay.
Adjunct
Okay.
professor. Yeah, it's
Okay.
already there. So one official goyal as a adjunct professor. Then I can include his name here, and then we can do a discussion with you as well in this what media. So what do you think?
Yeah. Yes, brother. I'll check with
Yeah,
Vishal Goyal and we
yeah,
can proceed.
yeah, definitely. Yeah, okay, brother. Yeah.
Okay, brother. Then that
Okay, see you.
when that AIP proceedings paper they will ask already
Yeah,
submitted.
it will be take a long
Okay.
journey, brother. So
Okay.
but right now we already collect all of them, and almost all already paid the
Okay.
publication fee, and then
Okay.
also we will send you to the authors the referee result
Uh,
from our review members. Yeah,
okay,
yeah, I
brother.
will send
Okay,
you
brother.
soon.
Okay, brother.
Might be today I will send you. Yeah,
Yeah, yeah.
okay.
Okay,
Yes,
brother.
yes, brother. Yeah,
Thank you. Thank you.
okay. See you then. Bye bye.
Yeah,
Yeah.
bye bye.
Ya, ya sudah. Assalamualaikum semua ya. Semangat ya. Ya. Saya
Waalaikumsalam.
live dulu. Ya.
Waalaikumsalam.